Hey everyone, how's it going? Welcome to the stream. So tonight we're going to wrap up the breakpoint change that I was working on, adding breakpoints to the DAP debugger, and then move on to implementing step over and step out. So I haven't actually committed the changes from last stream. Oh, hey, Jono. How's it going? So yeah, so the only thing I wanted to do, since the only thing I wanted to fix, no, I'm doing okay. To be honest with you, I'm a little down today. You know how they say that like everyone is gonna know someone like who's affected by Corona. Today, a good friend of mine, like a really good friend from over 15 years, someone I worked with at EA, and anyway, really good friend of mine. His family is in France, and all like his parents and his brother got the virus, and his dad just passed away last night. So kind of bummed out about that. Obviously, you know, I feel terrible for him and for his family. Yeah, it sucks. He said that his family was like in one of the worst areas of France to be hit by the virus, and that unfortunately, you know, like most people, they didn't take it seriously enough, early enough, so the virus spread like crazy, and yeah, it's pretty nuts. So yeah, but you know, trying to keep my mind occupied. You know, thankfully have a job and I'm able to work, and this stream is a welcome distraction. How about you? How you doing, Jono? This is really a crazy time. Yeah, thanks. I mean, obviously, condolences for my bud. But yeah, Europe is, you're right. Europe is definitely hit quite hard. Quite badly. Yeah, luckily in my own family, everything seems okay. And I actually have family in Italy, right? But so far, you know, so far so good. I don't know if they're just lucky or if they're being extremely careful. But I have quite a bit of extended family in Italy. So for sure, you know, I worry. Anyway, what are you gonna do? All right, so let me focus on this. Let's not get too down here. So the thing I wanted to do. So last time, in order to get stepping to work when on a breakpoint, I'm actually wondering if I should just do this. Yeah, let's commit what I have, and then I'll fix this after. So just to say what I was going to say is, I wrote a note about it here. So I said we check for breakpoints after executing instructions. So that, or after executing an instruction, so that stepping while on an instruction breakpoint doesn't keep hitting that breakpoint. So this was the bug that I had last stream, where I'd like put a breakpoint somewhere, we'd hit it, and then while on that line, if I'd hit F11 to, let's say, step into, it would just stay where it was. And the reason for that is that we were doing the check for breakpoints before executing the next instruction. And so it would say, you know, it would come in here and say, okay, check for breakpoints. Oh, look, I just hit a breakpoint. And then it would break. Then I hit step, so it would come through here. And I guess it's because stepping wasn't actually executing the instruction. So yeah. And this is quite a bit different from how I did this in my other debugger. In my other debugger, what I had was calls to stepping or executing instructions in different places. You know, like if you hit S enter, it would call the execute instruction right there. But here I'm changing it up a bit. I'm using a little state machine here, the concept of I'm running, I'm pausing, I'm stepping into. And this is why this is happening, because the step into here will run after the check for breakpoints. So what I'm going to do is, as I wrote here, fix this by remembering the what did I write here? That PC, the last. Whoops, fix that. Remembering the last PC, and only processing breakpoints if current is not equal to last PC. So basically, just making sure that we don't hit breakpoints again if our PC hasn't changed. And I think that'll be okay. Just give me a second. There's a little bit of noise over here. All right. Okay. So, yeah, I think I'm gonna, actually, you know what? Let me just do a quick little demo for those, who haven't seen. I always like to start off with a little demo of where we're at right now, what I did last time, and then we can move forward here. So, I'm just gonna build my debugger, build Vectrexy. We'll come here to VS Code. We're going to launch our Vectrexy debugger here. So that launches Vectrexy. I think I still have to attach, so I'll just attach my debugger here. Might need to disable some breakpoints. Looks like I'm okay. So we come back here, and there we go. So we are now in main.cpp, and what we did last time was the ability to set breakpoints in arbitrary locations. Like over here, I have a couple. I can add one over here, and I can even disable breakpoints. So I hit F5. So there we go. So now we're here, hit F5 again, here, and then there, and then that's it. We can go put a breakpoint somewhere in the main loop here. Let's say on ball.move, so we hit it. You know what, let me just do this just so we can actually watch. Yeah, that's one thing, is something I had done on with my other debugger was that I would not actually clear the screen if we were paused. So that would be kind of helpful here, because now you can see that it basically fades away. So that's something I'm going to add to my to-do list, because I definitely want that to work. It's useful for debugging. So we'll say don't render if paused in DapDebugger. Just like for CLI debugger. Which reminds me, rename debugger to CLI debugger. Okay. So yeah, so that's basically what we got working last time. So let's get that just committed over here. So I also I had internal breakpoints. I renamed breakpoints to user breakpoints, just so that it's clear what the two types of breakpoints are. Internal are the ones that I'm using in my debugger for stuff like, step into, and I'll be using it for, or like to break into main, to break at main, and I'll be using it for step over and step out, I think. Anyway, that's how I did it in my CLI debugger, so I'll probably do the same thing. So let's stage that. So for debug symbols, I actually decided to just move everything out and put it into the CPP file. So rather than keep everything in line, not only is it cleaner, but it'll also make it easier to debug while we're in a release build. So this is the DAP debugger. I think in the end I didn't use a string util, right? So let me reset that and see if this builds. Yep. So now we have a source root. We no longer hard code it. We use that there. So here's my to-do that we fixed. We've implemented set breakpoint request. So there's internal breakpoints for the main. This is the moving of check for breakpoints after the execute instruction. And then, oh yeah, and this is because now we have to check for both internal and user breakpoints. I put this code into a little local lambda that I called check. So let's stage that. Yeah, it looks like I had like a small formatting error, so I'll just put that in there. And that's it. Okay, so let's say DapDebugger implement setting breakpoints. Okay. Just looking to see if I should mention anything. Also now storing, or now no longer hard code the source root, but get it from the ROM path. Okay, sounds good. All right, so let's do this part here. Actually, last PC, I guess we'll clear it here. But in fact, once we've loaded a ROM, yes, it's a blocking call. We parse our RSTs. Ready to start debugging. Actually, do I want that? I guess I don't really want that. Yeah, that's fine. Okay, so let's go to our check for breakpoints. What we need to do is, after we've executed an instruction, we remember the last PC, so that the next frame we don't, it's different from the current after we've executed. So if we're checking the breakpoints, or I'll say if we haven't how can I say this? Don't keep breaking only break the first time. Only break the first time we only break the first time on the current instruction. This is to avoid breaking on the same breakpoint when stepping. Okay. All right, so this, if it works, should allow us to step forward when we hit a breakpoint. Let me just kill this. I didn't actually want to run it, just wanted to build it. Okay. And let me just remove the wait for breakpoints just so that we can wait for debugger attach. Okay. Hit a 5. And clearly I've broken something because this is not working anymore. So let's see, what did I do? Check for breakpoints. All right. This actually should be this way. Should it? Let me think. What's going on here? No, it should be updated after. What's happening is that we execute instruction and then we store last PC. So of course it's equal to the current one. So yeah, so I suppose it should be this way. Remember what it was, execute instructions. So the current PC will be different from the last one. Yeah. All right, there we go. Hit a 5. Hit our breakpoints, and now if I do F11, we are stuck. So we hit F11, and we go check for breakpoints. And our last PC returned true. Okay, let me just think for a second. Actually, I think this was correct. Let me think. Yeah, no, I see. It's not the last PC, it's the last PC when I processed a breakpoint. Yeah. Let's say we called it last breakpoint PC, just to see how that feels. So basically, if we check for breakpoints and it returns true, we break into the debugger and we remember what was the PC when we hit that breakpoint. This way, when we do step, it'll only execute that breakpoint once for that PC. But actually, that won't work either, would it? Because then if I hit F5, I won't re-hit the same breakpoint. It's kind of messy, actually. Maybe what I want to do here let me think for a sec. So we could be running, in which case we want to be checking for breakpoints. If we're pausing, pause on the next valid source location. So get the source location for the PC, and if we get a post location, why do I call it post? Oh, right, I see. Once we find a valid source location for the current PC, right? So finished executing instructions, that's what this meant. And then as soon as we hit it, we break into the debugger. So I suppose what we could do here, yeah, okay, all right, I have an idea. We'll get rid of this. I think this is what we need to do. Only check for breakpoints while we're running. Because when we're pausing, we're going to just finish the current instruction and then break. When we're doing a step into, what's going to happen is we are going to keep executing instructions, but we know that if, let's say, we hit a breakpoint, we're going to keep executing all the instructions until we hit a valid PC and break anyway. So we don't really want to hit breakpoints during that time. Now, we might want to do it for step over and step out. So there is maybe that. But that will still work, because when we do step over and step out, we will switch to the run state. Yeah. So that'll be fine. Well, it will switch to running, I should say. So yeah, this makes sense. I think this will work. Let's see. We've hit a breakpoint here. Okay, F5 is still working. And F11 looks like it's working. Let's put a breakpoint on a line that doesn't step into anything, that steps into something. So let's say this one here. F11 works. Okay. Okay, that looks good. And also, let's just make sure that if we have no breakpoints and we're running, and then we suddenly set a breakpoint here, it works. All right. So only check for breakpoints while in the running state. This allows us to set a breakpoint on the very first instruction. And actually, is that true? Did I actually change anything there? I suppose I didn't, because we still execute instruction. what we might need to do here is basically split the switch case so that we are checking for running, like we do the running before and the pausing and step into after. That's a possibility. Yeah, I didn't really change anything. Or not much anyway. Because basically, since we always execute an instruction, the check for breakpoints works even if we... This is exactly what I had before, except it was here. Although it makes more sense to me to have it here anyway, but I still don't have that ability to set a breakpoint on the very first instruction. And I'm trying to wonder if that's the only case I have to worry about there. The truth is, this is for user breakpoints. For internal breakpoints, yeah, we're going to miss it anyway. It's true. What do I want to do? Not sure. Not sure what the right way to solve this is. You know what I'm going to do? I'm going to think on this because I'm not sure anymore. What I might do, what I'm thinking right now is, what I might do is decide in which states we execute instructions and when, something like that. But I don't want to commit to that design just yet. And right now, this isn't terrible. It's a case. Right now it's just a corner case. You know, it's unlikely that I'll want to set a breakpoint anyway on the very first instruction. So I don't think we're ever even going to notice. So I'm not going to worry about it right now. So let's move on to. So let's say this is done. So let's do step over and step out. Probably do them both at the same time. So the way to do that is if we go look at my CLI debugger here. All right, it's called finish because I'm using the GDB terms for the CLI debugger. So let's see, we got finish and we've got next. So next is the step over and finish is the step out. So we'll start with a step over here. So what did I do here? If the instruction we're about to execute is a call, add a temporary conditional breakpoint on when the call stack returns to its current state. Oh yes, that's what I did. So I think the difference now is we don't want to put a conditional on when the call stack returns or we do, but we need it to be on a valid instruction, which is always the case. So what we could do is when we detect that this has happened, rather than break right away, we can enter the pausing state. And I think that's going to kind of be like the general theme. The idea is basically this, right? If we go to, do I have my RST file open? Yeah. I'll try and find a JSR, let's say. Okay, so here's a good example. So I'm just going to add some white space to kind of show. So if you recall, so this is like some code, right? And for a specific line of code, we have the following set of instructions. And then for the next line of code, we have all these instructions, right? So the thing is that this is a jump subroutine. What's going to happen is we're going to be here, and we're going to want to press, that's another problem, F11. Sorry, we're going to want to do a step over. Right now what my code does is it just says, is the current instruction a call? Now of course this instruction is not a call. It's more like, is the current source line's set of instructions, does it contain a call? Right? So I guess that's it. We'll add a state saying stepping over. And while we're in stepping over, we're going to keep executing and until, you know, we hit the next source line, like a valid source line. If we do, then that means that the step over is done. However, as we keep executing instructions, we're going to keep checking, is the current instruction a jump subroutine? And if it is, we don't actually want to step into it. What we want to do is we just want to execute it, so we're going to have to set a temporary breakpoint here on the next, or actually, what do? I just look at the call stack size, right? Yeah. So we're going to say just execute, don't actually go in there. Yeah, and we'll set an internal conditional breakpoint that says stop as soon as the call stack is back to the current size, which is what I'm doing over here. There we go. So when the call stack size is equal to the stack size at call, so we remember what the stack size was when the call occurred. So we're going to be here, let's say, and our stack is let's say 2 deep, and we're about to execute this, and we're going to say just run until we hit that conditional breakpoint that says that the stack size came back to 2. So then we should be here. And then at that point, we need to keep going until we break there. So that's the complexity here. And the thing is, I don't want to like analyze, you know, all the instructions that I'm going to be executing, because that's not great. I'm trying to think if there would be a way to store this as part of my debug information, because if I knew ahead of time, could I do something about it? Not really. Another complication is that when you step over, the behavior I want is that if you're stepping over a function call, but you happen to have put a breakpoint in that function or somewhere deeper on the stack, we actually do want it to break. So we're going to make sure of that as well. So I'll try to handle that after. All right, so let's just kind of try to code it up and see what it looks like. And actually, the more I think about it, the more I think I will have to control execute instruction within each state. I think that's sort of required for this to work. Something like yeah, I don't know why I had this at the bottom here. Could be in here. Oh, it's got the same name. So this is my CLI debugger. You can see that when I step, I actually do the execute instruction here. Okay, so let's say that case. I'll just put it here for now. This is where I might move it below. And then let's add a case for step over. Oh, I already have it. Very nice. Interestingly, I didn't get a warning about not handling all cases. Just kind of odd. It's not like I disabled that, I believe. Normally, there's a warning that gets emitted when you don't handle all the enum values, right? Which is a good thing. All right, so step over. So what are we going to do? So we're at some instruction. We're in the state stepping over. And we want to keep stepping, keep executing instruction. If the current one is a call, then we're going to do the conditional thing. Okay, so let's do that. And one thing I don't remember, next, did I add conditional breakpoints to my, yeah, I need to add this as well. Oh, it's part of breakpoints. Okay. Okay, so we need this function isCall to be externalized. I'll put it in my utils. Debugger util. Okay, so now we've factored that function out and we can use it as well. Okay. So now the thing is, we're going to do this and we're going to keep running, but we don't actually want to break if we hit a conditional break, an internal conditional breakpoint here. Which is why we need to check for breakpoints differently, I think. Yeah, so this is a case where if we hit a conditional breakpoint, so I guess maybe it's not the same thing as check for this. It's yeah, what do we want to do here? Yeah, because if we do it in the, if we check for conditional breakpoints in here, then we're going to end up being paused. We were using it here. Yeah, it's this weirdness of like the whole idea of being within an instruction that's awkward. So maybe what this means is that if we hit a breakpoint, we should enter the pausing state instead. That's what I think this means. Rather than break it immediately, because we basically always want to break as soon as we're on a valid first instruction of a source line. You know what I mean? So, because this is a source breakpoint, like a source line breakpoint. So if I come back to my RST, you know, if we set a breakpoint here, we want it to keep going until, well, actually, is that right? Yeah, actually 99% of the time what's going to happen is we will have set a breakpoint on the first line here, and we'll say keep going until you hit a breakpoint, but of course we don't want to execute another instruction, so that's a bit of a problem. Yeah, I gotta really get this right. This is more of there's something not quite right in my design, so I need to make sure I clear this up, because I don't want to have like weird hacks and stuff. I do want check for breakpoints to be the single location where we check for them. So I just got to figure out the right abstraction here. So what I'm thinking, like I said, is say we were instead of doing this, we've hit a breakpoint. So let's say that means we set our run state to pausing, right? So we'll say make sure to stop on the next valid source location. The only problem I have now is that we will end up executing another instruction if we do that. So maybe what this means is we should do this after, but that might cause other problems. So you know what? Maybe what this means is that it makes sense. Okay, maybe what this means is it makes sense to go back to, okay, let me just put this here for now. I think if we sacrifice that idea of breaking on the first instruction, if we always start by executing one, then checking for breakpoints, and if we hit one, we say go to pausing, then in pausing, we will get the current PC. It is should be a valid location, and we should break on it. Yes. And let me think, pausing. If you hit pause like somewhere, oops, here. Okay, so if you hit pause, that's fine. That works still. That should still work properly. Yeah. Yeah, I think this makes sense. We'll see. We'll see if it works. So, all right. So we add, okay, so that means we need to go and add a check for internal breakpoints in our check for breakpoints, just like we do in debugger here. And I guess here we'll say if should break, return true. Yeah. Okay, so now what would happen is once we hit that conditional breakpoint, we will enter pausing, at which point we will continue to execute instructions until we hit the next location. That's what it should do. So yeah, if we hit step over, we should go into the running state. So the only thing that this doesn't do correctly is what I was mentioning before, which is that should we hit a breakpoint inside the function, our conditional will still be there. Like, you know, let's say we go back to main here. So let's say I put a breakpoint here, we hit this breakpoint and I decide to do step over, or whatever. We do step over here with F10. But inside the move, I had put a breakpoint. You know, we go into the, into here and we put a breakpoint there, right? So we do expect to hit this one, and that would be correct. But it also means that our conditional breakpoint that would break it right on the, on the outside, right? We also had expected it to break here, right? But if we hit any other breakpoint, we should clear those conditionals. That's what it means. And I feel like I did the same thing in my other debugger, because this is ringing a bell. Oh, I guess I didn't. So that's probably an issue that I have right now in my CLI debugger. Okay, so we'll handle that after. Let's just see if this actually works. Now, if we are not on a call, then we just keep going, I suppose. We are in step over. Yeah, we want to remain in this state. And we want to remain in this state until we've hit the next valid instruction. So basically the same kind of thing we have here. Exactly the same. So you see this code is repeated, right? So we're going to extract that because I need this in all three places. What should I call it? Break on, sorry, how we say, break if valid source location. The only thing is, though, there's a different event that I need to send. DapDebugger event. Whoops. we are in the DapDebugger scope, so I can just put event here. Event paused, and here it'll be event stepped. And then similarly, event stepped. Because basically, if we don't ever execute a call, behave like step into, and break on the next valid source location. All right, so if I didn't mess anything up, which I may have, this should work. Let's find out. Let's get it to compile first. What was I doing with pre-location? Why did I lose it? Oh, I must have made, let me see here. Maybe it's not so simple extracting that function. Let me go take a look. Might have been prematurely recognizing it as being the same. Oh yeah. Yeah, okay. This is not at all the same condition. Yes. So here I was saying, get the post location. We have the pre-location. If the pre and the post are valid and they are not equal to each other, why did I do that again? Oh, right, because of the multiple instructions. Yeah. Yeah, so it's not exactly the same location. So what we do is we grab the pre-location of the current PC, and so basically we're okay, so what this was about was that concept of we are doing a step into, and we are making sure that, let's say we're somewhere here, we only want to break when the source location we're currently in, so this one that's represented by this line, let's say line 36, that we only break once we are no longer at an instruction that's part of this block. That's what that represents. So yeah, I can't do it this way. Yeah, because you can see here, clearly this code is not the same here in the condition. Okay, so let's say we just leave it like this before we factor it out too much. Because the other thing that was running through my head is, do we sort of want to do the same thing as step over for step into? No, we don't. In the sense of step over will work by setting a conditional breakpoint and then going into the running state. Which is a bit weird, right? Because it means we were stepping over and and then it's going to say we paused. Is paused correct? We should be saying that we stepped. In fact, there's pause, there's stepped, and there's breakpoint hit. We need to tell the debugger the correct event. Okay, so the more I look at this, the more I keep thinking we need to do this check in each state. If we're in the running state and we hit a breakpoint, breakpoint hit. If we're in the pausing state, we already do the check for breakpoints in here. So there's no need to do another check here. We're just looking for as soon as we hit a valid location. So that should be fine for pausing. And if we're doing a step into, so actually step into as well, we don't need to check for breakpoints because we are stepping into. So we will keep executing instructions until our current finish executing current source location instructions and break when we hit a new source location instruction. So that's what this is. However, for step over, yeah, and then I'm going to run to that problem I was saying before of should we hit another breakpoint? But maybe that's going to make it easier for us to handle. Yeah, because here I could say, you know, to clear these. Or like erase all as I had in the other one. Debugger breakpoints. Or maybe I don't remove all, but I want to remove this one anyway. Okay, for now I'll just do this. In case we hit, yeah, that's the only thing, is that I don't know if I hit which kind, because the event that I report here should really depend on which breakpoint we hit. So maybe we should return that. Yeah, so I'll think about that. For now, I'll just ignore it, but I'll put a to-do here. In case we hit a non-conditional. We only remove the one we added or step over. Bring it to debugger, and then here to do, because I'm going to put here stepped. To do, this may not have, or send event breakpoint if not from a, or if breakpoints returned true, or I'll say if we hit a non-conditional breakpoints. So we execute an instruction, we check for breakpoints. I mean, I guess I could check for this after. So, okay. So, whoops. Why does it keep doing that? Okay, so we execute an instruction. We are in the step over. We see if we are at a call. So actually, once again, we probably don't want to execute the instruction here. So I'm going to start moving this in. So, because the thing is, if the very, very first instruction that we're at is a call, we need to make sure that we catch that. We don't want to miss it, right? Before we start executing. Then we can execute and check for breakpoints. I think that's what we need to do here. Let me think again now. We've got break into debugger. Do execute instruction. back after. Remember the pre-location. So actually this, in that case, can be moved in to here, which is actually better because it's localized to step into here. Does this build? Okay, so let's see if it still works. So first, let's just do normal F11. That's still working. We'll put a breakpoint here and hit F5. That still worked. F11. So now we have to select a game. We're back here. That's good. So F11 is working. So let's try F10. And F10 is not working. This is what I was afraid of. But that's okay. It looks like we didn't break the other ones. The fact that F10 is not working is okay. So let's attach ourselves. Oh, I know why it's not working. We haven't set ourselves into the step over state anywhere. Here it's called the next request. Why do I even set this to false? Yeah, I do this everywhere. Continue. Oh, sorry, yeah. Paused equals to false. For next, we should also have, we should be in the pause state as well. And we no longer want to be paused. Exactly. Okay, yeah, that makes sense. So then, let's try that. Okay, let's hit F5. Let's hit F10. So F10 brought us there, which is weird. It is clearly not working. It's doing something though. Okay, so let's see what's going on. Let's put this here. I hit F10 here. Oh, yeah, I should probably attach. Okay, so I have a simple instruction here, so I'm going to hit F10. We hit our breakpoint. Move this a bit more. So we are currently in the running state. We're going to go into step over. Let's see what happens. So we should hit this next. I'll put a breakpoint up here. Here we are. So now we're going to look at the current instruction. Is it a call? It is not. So then we execute the instruction, keeping in mind that that just does the execute and updates the cycles left. Good. Then we check for breakpoints, which we hit none of. We're still in here. Oh, right. Yes. Okay, I forgot that's what this else branch is for. We need to behave like step into in case we don't hit a call. That's what's going on here. Yeah. I just had this evil thought. I'm just going to do it because it's evil and I just want to have some fun here, but I am going to fix this after. But what I'm going to do is I'm going to say go to step into. Can I do that? Yeah, maybe I can't do it with this because it's an enum class. Alright, forget that. Let's, for now, just copy this and see if that works. And in fact, it has to happen after we execute the instruction. Right. new source location. If we write a new source location or check for breakpoints returns true, basically we want to do this. So let's try that again. F10, we enter a step over. Is it a call? No. Execute the instruction. Are we at a new source location? False. Right. The other thing too that we have to make sure of is if we are at a new source location, or actually no matter what happens, we're no longer in the step over state. We're done stepping over at that point, right? Actually, it doesn't really matter because we get paused. So why does that matter? We won't execute anything anymore, so that's not the problem. Okay, so let's just see what happens here. Hit F5 again. Are we at a call? No. New source location? No. So we made it to the new source location because there is no call, obviously, for this. We clear. Well, there's nothing to clear because we didn't have any. And then we're going to break. And we're going to say we've stepped. And then at that point, we return. And that actually seemed to do the right thing. We are here. Let's hit F10 again. That did the right thing as well. F10. It's annoying how it keeps getting focus. So we just came out of the move. Okay, that's because I actually have a breakpoint in here. That's the case that I guess I'm not handling, or I guess that I am handling it. But okay, so here is an actual case where we have a function call. So let's see what happens in that case. So I hit F10 here. Well, what should happen is we should not go into it. We should step over it. So we should eventually hit the isCall. So I'll just put a breakpoint there. And I'll put a breakpoint inside here. I'll hit F5. And somehow we reached here. Why is that? We did not detect the call. Let's try that again. So once again, F10. So the current instruction is not a call. Okay, so this time I hit it. Stack size at call is 2. Oh wait, maybe it did work. Internal conditions, we add 1. So I wonder if I can put a breakpoint in here. Cool, I can. And then we execute the instruction, the call. So we are now inside the move function. And I think what's going to screw us here is the fact that we are now considered at a new source location. Because we are definitely at a new source location. So that's actually a problem. So we do really only want to do the source location check in that else branch. No, it's not. That's not the case. What do we want to do? Once we've added a conditional breakpoint, we know we've made a call. Now we just want to keep executing until we've hit that that specific type of breakpoint. Right. Whoops. The complexity of this code compared to my other debugger is this whole concept of the fact that we have multiple instructions per source line. So I feel like I need to solve this more generally rather than doing it per instruction the way I'm doing it here. Like I'm thinking, just like how I have a pausing state, maybe I'll need to have some kind of like stepping state, you know? So that's something I'll probably gun for once I see something working here. But I think what I need to do now is more like if can I actually check this here? Because every time we step over, if we know we've added a conditional, it means we will break. Yeah. Yeah, we don't want to do the new source location thing at that point. Okay, if we added a conditional breakpoint and check for breakpoints, so basically, if we know we've added a conditional breakpoint, then we only want to check for breakpoints. Otherwise, we want to see if we've hit a new source location, which means that there was no call that was made. So either one of those things will get us to break. Let's try that. All right, so let's try here. We do F10. Huh. So it sort of works, but there's this one F10 that doesn't do anything. I have to kind of double up. But what it means is it's doing something when there's a call. See, normally F10 is working. Here is a call. And did I have a breakpoint here? So for some reason it went in there. Yeah, it's not quite working yet. So this was the example I had before. So let's see why it's doing this. Getting closer. Get it to work first, and then we'll clean this up. All right, so we have a breakpoint in there. We'll put one in here. We'll put one in there. Okay. So we got a call. So now we're only checking for if we've hit that guy, which means that at one point Oh, we're checking our condition here. This is the checking of the conditional breakpoint, so we don't need to do that. So break is false. Hit F5. So I think what's happening is probably the same thing as before, which is to say, when we break into the debugger, it's that same problem as before where we did not execute. When we hit F10, we will step over right. Tricky. Yeah, I know what's happening. It's the same problem. Basically, when we do, when the conditional breakpoint triggers, it means that the call stack size changed. But we are now at we are not yet done our current instruction. We have to finish executing our current instruction until we get to a new one. Yeah, this is quite complicated by the fact that we need to always finish executing a set of instructions for a given source location. It's always the same thing. I need something. Oh, hey, Blue Dragon. I don't. I just got here. I think I lost the context. What were you responding I don't to? I think I know what's going on here. Yeah. It's okay. I'm pretending that I know what's going on here. So you and I are actually probably in the same state. I'm just thinking about how maybe there is a different approach that I can take. It crashed. Yeah, so what I was just thinking about is the complexity of a lot of this is this notion of iterating. I'm at this lowest level. I'm iterating instruction by instruction, but to find out if there's a call. But if I knew that there is a call for the current source line at the very top, let's say at the very beginning, so say I go into, where's my RST file? Here. So let's say when I'm here, I know that there's going to be a call because I have a jump subroutine. Then I could actually, right at this moment, create that conditional breakpoint and say, all right, you know, like we're going to stay in the state because we know we're going to hit a call and all's good. If I know that there isn't a call, I just do a step over, like a step into. or whatever, the same thing as a the same thing as a step into. So when there isn't a call, just keep stepping until we hit the next instruction. In fact, I could just change state to step into. So this would require that I have the knowledge that there is a jump. There is a call in this. And I might be able to do that, but that would mean adding that information while parsing. And then there's also the question of, will I necessarily be, I guess I am going to be always at an instruction like this when we decide to hit F10, step over, so then I could look up the information for the current source location. So this would mean adding like another flag. The source location is a file and line, and also will tell me, is there a call? In fact, what happens if there are multiple calls on a line? Yeah, it doesn't really matter. As long as there's at least one call, we want it to step over the whole thing. But actually, then if there are multiple calls, what's going to happen is we will break in between. What a pain in the butt. Because what will happen is we'll step into the first call, our call stack size will change, and then when we'll come out, we'll say, oh, our call stack size is restored, but we haven't actually executed the next call. So that's actually kind of funny. So our F10 will remain on the same line. Not quite true though, because the idea would be that when we hit our conditional breakpoint, we keep stepping until, like, we basically resume stepping until we hit the next valid source location. So it should be okay. So yeah, maybe that's the approach I need to take. Okay, so before we do that, I think we can still get this one to work, and maybe I'll move towards that later. What I think I need to do here is something like this. So if we do have conditional breakpoints and we hit one, we do all this. I do wonder why I put these returns in here. Don't think I need those at all. Anyway. Okay. Now, on the other hand, we just keep doing this. Okay, and actually, no, that's it. If we check for breakpoints, and we come in here, we remove them, we don't break right away. That's the key. The key here is that we change our state to step over, to step into. Is that right? Yes. I think so. So we need to finish executing instructions for the current yeah, we need to finish executing instructions for the current source location. Which is what step into does. And then if we don't have any of those, we do look for new source location, and in this case we do a normal break. And in fact, yeah, yes, okay. There's also this concept of the, yeah. The only thing about this is that if we broke due to a breakpoint, we don't actually want to do this. So that's my to-do here. Handle not for conditional to do something different here. Okay. Whoops. I hit my desktop key. Lost all my windows. Kill this debugger here. Okay, let's try this again. Still not working. So it sort of works. On those ones, it seems to be doing the right thing. Let me make sure to remove. No, see, I don't have a breakpoint in here. So see, why did it go into update audio? I don't know. I was here at wait frame and I hit F10. So this is a call. Huh, that's cool. I didn't even, it's the first time I see anonymous namespace in the call stack here. So yeah, why did it break here? So that one worked. It's this wait frame seems to always go into update audio. This one's okay. So let's see what's happening there. Okay, so we hit F10, step over state. Oh, really? Already a call. Let me go see something here. I guess it would make sense that there's a call instruction because there's no parameters to pass or anything like that. So the very first instruction should be a call for this. I just like to make sure of that. So this is base.rst. And we are at line 516. Comma. Oh no, sorry, not 516. What am I saying? Base. Oh, is it base? No, it's BIOS. Okay, sorry, that's wrong. Let's go here. Yeah, sorry, we're in main at line 113. There we are. Yeah, okay, so this is just a simple jump subroutine. So this is actually, should work. This is an easy case. So let's see what's going on here. So the stack size is 2. We say add a conditional breakpoint. Now the conditional breakpoint says as soon as the stack size comes back to 2, we should stop. You know what would be helpful is if we actually did, if we put something here, but it's all right. Okay, now we go and we execute the jump. We're not empty, and we're going to check for breakpoints. We haven't hit one, which is great. So then we're going to come back here. Oh, I see. So annoying. So what's happening here is that we are now in the process of executing this, and there is another call, so yeah, that's no good. Waiting for step over I don't know what to call this. Waiting. We're waiting for call return or something like that. If we are not waiting for a call return and the current instruction is a call, you know what I think we need is I probably need to add another state. That's actually what I need to do. Yeah, I'll do that after. And then over here I can just replace this check with that. Now, kind of like the problem is that I have two states here in one. Where in step over, and basically we are stepping until we see a call. Once we've seen a call, we should go into another state that's like just, wait for the call to return. Exactly what I wrote here. And in that case, we're just going to be doing check for breakpoints. Otherwise, we stay in this here and we can check for the new source location. That's actually the way to clean this code up. The reason why it's getting complex is because I'm mixing two states in one. Still not working. Pain in the butt. I think I just realized the problem. Yeah, again, this would be fixed by just changing state. So the problem was that I set this bool here to know if we were waiting for a call return. If we do enter this, then we need to reset it to true. It should be true at that point. I mean, alternatively, I guess I could just do this. If we're not waiting and we come in here, we're going to set this to true. And after that, and that's true, and then so when we come back here, down here, we'll check for breakpoints. I keep thinking about this idea of knowing whether the current source location has a call or not. I like the idea and I think it might simplify things, but on the other hand, it means I need to detect it while parsing. And I kind of don't like that idea very much. Because when I'm parsing, I don't actually care about the instructions. I just care about the address. And now I'm going to have to actually look at the instruction. And the thing is that it's not like an opcode, you know? I'd have to like disassemble it. So that's sort of the one complication here of that idea. So I'm not a huge fan of it. So I'm going to try and keep making it go with this sort of instruction by instruction state machine. Pretty sure I can get this to work this way. Okay, so here we are. If I hit F10 here, F10 is actually behaving like F11 again, so that's not right. Oh, it did not compile properly. I knew that because my breakpoints were disabled, which means that the source code doesn't match. So why did I get that? Okay, let's try again. No, still not working. But let me see when I attach what happens. Just go a bit further out here. Okay, so it is currently the right version. Okay, so we hit the call instruction. So we are now waiting for a call return. We add our conditional and we check for breakpoints. We don't get one. So this is still true, yeah. Right, so this is going to be a while because I'm ostensibly executing over and over the instructions in move. So let's just put a breakpoint in here. And we should never reach here. In fact, we should never reach this else anymore. F5. Okay, so there we go. So we just executed an instruction that returned us back to the same stack level. So that really should be the rest of this instruction. See, what I do now is I go into the step into state, and then when we do that, we're just going to keep executing instructions until we finish executing the current source location. So that should finish. Yeah, does that make sense? Let me go look at this in the RST file. Okay, so this is the jump subroutine. So technically speaking, when we've when we've executed the return from that routine, we should now be here at this instruction. At 0D37. So let's see what our PC looks like right now. Yeah, 0D37. So we are actually there. And if we switch to the next state, we should basically execute this instruction and then break as soon as we come to here. At 0D, wait, yeah, D37. We should stop at 0D39. So let's see what happens. Step into is here. So we change our state, and we're now in step into. We're still at 0D37, which we now execute. You see now we're at 0D39. This should break now. Yeah, there we go. Break into debugger. And the current source location at 0D39 should be at line 132, which is here. So we're going to say that we've stepped. And then the debugger is going to ask us where we are right now. Source request. I think this is what we're going to get. No, sorry, not this one. We're going to get a which one? There's stack trace. I think it's the stack trace one, yeah. Is it? No, that's just to populate the call stack, so that's not the one. So it's not scopes. Yeah, actually, how does the debugger know which line to show next? Getting a little tired. I'm gonna have to probably stop soon. Yeah, I'm not sure what's going to happen here. I don't really understand. Basically, we should fall on line 132, but we don't. See if I hit F5. We are getting the stack trace event request here. Whatever. Wait, so that worked? What the hell? Okay, I'm thoroughly confused now. Wasn't this like not working? Just remove all my breakpoints here for a sec. In fact, let me just detach. Okay, so these are actually working. Ah, so there's a case where it didn't work. Okay, so it's not completely broken. It just really depends. So here's another case where it didn't work. Set string. Yeah, okay. So there's some cases where it doesn't work. For example, here for the draw, it's not working as well. So let's say we put a breakpoint there. Because for wait frame now it's okay. For this one it's okay, right? Actually, even wait frame is not okay. You see we're not at 116, we're at 117. And I was actually afraid of that because I was thinking, yeah, if when we come back from the call stack size being changed, we are at a new instruction, we need to stop. Like we don't need to go and do a step into. Wow, what a pain. Okay, I think I'm going to call it quits. I understand what's going on. I understand the problem. I need to think a little bit about the right way to solve this because I need to find a better way to represent the state machine. I got to think a little bit about this general problem of a block of instructions for a source location and what would be the best way to manage that. Because yeah, See, this is what made like the instruction level debugger easier to write, because you just execute one instruction. But here we have all this complexity of these blocks of instructions. Yeah. This is way too complicated. Yeah, what I was saying before is the reason why we went too far is because we don't really want to go into step into if we've already changed location. So you see how this, like the pre and post check thing, we would need to see if we're actually at a new source location. And in fact, we wouldn't be able to do that here. Yeah, this is quite complex. All right, so I'm going to think about this, reflect on this a little more, try to come up with something better. And then hopefully by next week, on Tuesday, I'll be ready to implement this thing properly. So yeah, thanks for watching me struggle tonight. And hopefully I'll see you guys next week. So yeah, take care.